So this is March 2022. Paper is 52. The threshold is 20 out of 30. It's a good low threshold paper. So share the threshold, copy the threshold.
Okay.
And now a student has a sample of copper. A student has a sample of copper 2 sulfate crystals. The student wants to show that the value of X is 5. The student uses the following method. Weigh a clean crucible on a balanced reading to 2 dp, record the mass, place the sample of copper sulfate H2O into the crucible, record the mass, heat the crucible gently for about 1 minute, then strongly for about 4 minutes. Weigh the crucible and contents, record the mass. Identify the instruction that is missing between step 3 and step 4. So what are the 2 steps missing? Step 3 and step 4, because when something is hot, can you directly weigh it or you should allow it to cool? If something is very hot, he says strong heating. So if something is very hot, should we put it on the weighing machine or it can be problematic?
No, we should let it cool first.
Good. So explain why gentle heating takes place in step 3. When you're heating gently, is it a precaution against possible decomposition? Like when you are heating, when you're cooking, when you're heating for cooking, you do not go for very quick heating because it can denature the food. So can we say that it's to prevent any decomposition of the copper sulfate?
Yes.
So we can say that we are preventing any decomposition.
Yes.
Name the apparatus that should be used to hold the crucible during heating.
I think it's the triangle.
Triangle. What is
The
you're saying that which is like a holding clip, that one?
yeah.
Hmm. During heating. So we can say that heat, that is a possible thing.
Can we also say tongs?
Tongue is also there, but tongue crucible is not so small. It will be, then it will be moving a bit. That
Hmm.
the triangle, the method is incomplete. State the steps that should be carried out to complete the method. What's missing here? Weigh the crucible and contents, record the mass. What he is willing to do. Acha. He says that the student wants to show that the value of x is 5. So the student has weighed it in the start. The student has weighed after heating. So after heating, water of crystallization must have been removed. Water of crystallization have been removed. Now it's only the difference in mass. The difference in mass will be the mass of water. The difference in mass will be the mass of water of crystallization. And this mass of water should be converted into number of moles of water. And if it matches with 5, the answer will be complete. So what should be the more steps? If I say step number 5, heat again few times until mass is constant. Heat to constant mass. Step number 6. Subtract the initial and final masses. And the difference will be the mass of water of crystallization.
Hmm.
Divide it by 18 to find n. Okay, have you done it?
Yeah.
Good. Now we move forward. This is the student record their results in the table. Mass of crucible plus contents before heating, before after heating, after experiment. These are the readings. Calculate the experimental value of X from these results. So what should we do? We have three values. How should we know what is the mass of water of crystallization and what is the mass of copper sulfate? Should I subtract 13.6 and
We can
21.09?
subtract
Hmm?
21 and 13.
I was thinking if I subtract 21.09 minus 13.6, what I will get? You have to copy this. Okay.
Sorry, I got disconnected.
No problem. Can you subtract it?
Yeah, it's 7.49 grams.
Sorry, how much?
7.49 grams.
7.4.
9 grams.
Okay, now what 7.49 grams shows here in this part? Seven point four nine gram. I think it is the total mass of copper sulfate with water. What do you think? I think this is the mass of copper sulfate with water. Now, this is a I have it number. Now, what about if I subtract 21.09 and 17.94, what I will get? Will I get the mass of water? 21.09 minus 17.94. Can you make this subtraction? Okay, can you make it subtract?
Hello, sorry again.
Or
It will be 3.15 grams.
3.15 gram. Achha, I was thinking that this 3.15 gram should be the mass of water.
Shouldn't we subtract
Mhm.
um
I
from
have the
7?
mass of water. What about mass of copper sulfate? If I subtract 7.49 and 3.15,
Yeah,
so 7.49 minus 3.15. You have to subtract that.
it will be 4.34.
What should I do now? Should I make a ratio of these two masses?
Shouldn't we divide the mass of water by the MR?
Mhm. Right. Let's make it the moles. Now, what is the mass of copper sulfate? So, what is the molar mass of copper sulfate? Can you find it?
Yeah. It's 159.6.
Okay. Now divide them.
For water, it will be 0.175. And for the copper, it will be 0.0272.
0.0.
272. It's coming out to be a 6.4.
Ooh.
I will double check the values.
After a long effort, it is not coming fine. But it can happen. It's not a paper 4 question.
Mm.
Whatever is coming, we have to take it. Have you double checked it?
Yeah. It's still the same.
Hmm. So let's keep this number with us. Suggest why the experimental values of x varies for the expected value of 5. If you are unable to obtain an answer, you can use the experimental value of 6.9. This is not the true value, but anyways, he says your answer is not. I read part 2 and I was sure that we are going right because he's also telling that the answer won't be coming correct.
Mm.
Experimental value is more than 5. It means somehow copper sulfate is less than in its original value. So one possible answer, which is like a memory answer, is the presence of impurities.
Okay.
The empty crucible weighs 13.6 gram. Calculate the percentage error. It's again the famous 2DP case.
Yes. So it will be 0.01.
So we can use that 2DP working. So the empty crucible weighs 13.6 grams. So should we take it twice the percentage?
Yeah.
So 2DP. Let's start our work. This is a permanent mathematics thing. 2DP means 0.01.
Yes.
And in our O-level GCSE math, we call it bounds. So the bound will be 0.01. We always have it 0.05. This is called the concept of error in rounding. Now we read it twice. Empty crucible weighs 13.60.
So I multiply by 2 since we're taking it twice.
Good. 2 multiplied by 0.005. And the number we have reading is 13.6.
Yes. It will be 0.0735.
The conductivity of an ionic solution can be determined by passing an electric current through the solution and measuring the conductivity using a conductivity meter. The student carries out an experiment to measure the conductivity of different solutions of ethanoic acid, which is a weak acid. Okay. And the acid dissociation constant can be determined from this experiment. The student makes standard solution 250 cm cube of 2 mole per dm cube ethanoic acid. What is meant by a standard solution? Is it standard solution is that for which we know the concentration?
Yes.
Describe how the student should make standard solution A from pure ethanoic acid. The concentration of standard solution A should be 2 mole per dm cube to the nearest 3 sig fig. Acha. Your answer should state the name and capacity of any apparatus that the student should use. A balance is not available. He's very clever. Pure ethanoic acid is a liquid with a density of 1.05 gram per cm at room temperature. You may wish to write your answer using a series of numbered steps. Molar mass is known. So we can first mix it in a little volume of water, distilled water.
Yes.
What volume should we take? That's the first thing to discuss.
Can't we take any volume?
No, actually, then how we make the required solution? That will be a problem now. Because 250 cm cube of 2 mole per dm cube. If we want a high concentration of 2 mole per dm cube solution, and the volume should be 250. So I was thinking we can find the moles here, and we should see that in a sample, in a beaker, he needs that the concentration should be 2 mole per dm cube to the nearest 36. Density is given. I was thinking density is equal to mass upon volume.
Mm.
See how much volume it comes.
57.1.
How much? 30,
57.1.
57.1.
Yes.
So we can start with this volume. So we have the density. So there are two possible ways. Either we go by the number of mole method, or we can try this density method. I have an idea that we can find the number of moles. We can find the number of moles in 250 cm cube of 2 mole per dm cube. And we have a theme to remember that dilution does not change the number of moles. Dilution does not change the number of moles. So we can find the number of moles from 250 cm cube n is equal to Cv. And once we get the number of mole, we can find the, let's try this routine also. Double check that if we use it's 2 mole per dm cube 250, we need the starting volume, which is should be not very high, so we can put it in a beaker.
It's 0.5.
30 gram. Even this mass is coming high. It's a very strange data then. Even this mass is coming on a higher side. Anyways, we got the mass. Density is equal to mass upon volume. So volume is equal to density. Volume is equal to
It will be 28.6.
That looks logical. 28.6. 28.6 we take in a beaker. Twenty-eight point six cm cube. What apparatus should I take? Should I take burette?
Yes.
So what should I do? Next step, should I transfer it to a volumetric flask?
Yeah.
I have to fill it till 250 cm cube mark. Using distilled water. Okay. The student wears chemically resistant gloves throughout this procedure. Why? I think we have an issue here. Let me recall again. The pure ethanoic acid, is it in solid form or is in? Mhm. Actually, it is a liquid with a density. So I think in our first step, we should mention that we should take this acid. Acha, we have said, I thought we should take it in a beaker first, but I think in fine and pure, fine. Good, that's fine. Okay, now the student is wearing chemically resistant glove, which can resist acids and other things. So why has he, because it's an acid.
So it can catch fire?
No, acid itself is dangerous, na?
Yeah.
And you know that we need always good care.
Mm.
All acids. Normally, acetic acid, this one is very mild. It doesn't hurt, but it's pure.
Mm.
Normally, ethanoic acid is not harmful. But why we need care here? Because we are using here, look at the see, he says pure ethanoic acid. So pure means it can be dangerous. Acids are by nature corrosive.
Okay.
The student dilutes standard solution with distilled water to make solutions of different concentrations. The conductivity of these solutions is measured. The figure shows the result. Molar conductivity. How is getting molar conductivity? Actually, is he multiplying it? Column 3 is the reciprocal of the square root of the concentration. Column 4 is the molar conductivity, which is found by dividing the conductivity column 2 by concentration column 1. Column 2 divided by column 1. Okay, so let's start filling this table.
Okay. For column 3, the first one is 4.47.
Can you repeat the first answer?
Yes, 4.47.
Okay,
Sorry, it's 4.47.
okay.
Then it's 6.32. And 8.94. 12.6. 17.9. 25.3.
Column 2 divided by column 1.
The first one is 0.0752.
Sorry, 0.
0752.
Okay.
And 0.110.
0.
110. Zero point one five four.
0.154.
4. Yeah.
Then
Then it's 0.213. And 0.368. And it's 0.428.
identify the dependent variable in this experiment, which is changing on our interference.
The conductivity.
Mhm. The student decided to measure the conductivity of distilled water at the start of the experiment. So when he is measuring the conductivity of distilled water, so we can use it for calibration.
Okay.
State one variable that should be controlled. Should we control the temperature?
Yeah.
Temperature is commonly the most interfering variable we have. Oh, graph. Let's see how much we can do in the coming minutes. This is a big graph. Conductivity on y-axis and okay, this under root thingy on x-axis. 4.47. .32 into 0.110. Where is 6.32 then? So let's keep it up to here
Okay.
and we can do it. So let's try it in our next class and we will inshallah try to complete this paper. So we are keeping it
Inshallah.
up here. We will continue in our next class. Thank you.
Okay. Thank
Allah.
you.